Hello everyone, I hope you are doing fine. Welcome to the collaborative activity for module number 5. In this video, I will try to explain you a theory of constraints example. It is very similar to the first two problems that you will solve in your collaborative assignment. It is important that you see the problem diagram that was posted on Blackboard in order to check the solution procedure. Here we have the diagram. In this problem we have two products, P and Q, and the target is to get the mixed product that will maximize the net profit per week by using the theory of constraints philosophy. In step number 1, you need to get a constraint. In this step, you have a list of 4 machines, A, B, C, and D, and we calculate the minutes that every product needs on each machine. In the solution sheet, we found out that we have 25 minutes for machine A, 45 minutes for machine B, 20 minutes for machine C, and 15 minutes for machine D. According to this analysis, we can conclude that machine B is the constraint. In step number 2, we need to perform a constraint analysis. And for this analysis, I propose you a table. In this table, we have the product P and Q. We have the demand, 100 units per week for P and 50 units per week for Q. We have the sale price, $90 for P and $100 for Q. The cost of raw material, this information can be obtained from the diagram. For example, for the P product, we need 1 unit of raw material, $20, 1 unit of raw material, $20, and 1 unit of the purchase part, $5. So we have $45 for raw material just for product P. The margin profit is the sale price minus the cost of raw material. So for the P case, we have 90 minus 45, and we get $45 per unit for the P product. In the Q case is the same, and we get $60 per unit. Constraint, machine B for P and Q. Time on constraint, 15 minutes for P and 30 minutes for Q. Pieces per hour. If an hour we have 60 minutes, and we divide 60 minutes over 15 minutes, we get 4 pieces per hour for P, and 60 over 30, we get 2 pieces per hour for Q. The profit per hour is the margin profit times pieces per hour. So for the P case, we have 45 times 4, and we get $180 per hour. For the Q case, we have 60 times 2, and we get $120 per hour. Now the priority production will be the maximum value of the profit per hour. In this case, the priority will be number 1 P and then number 2 Q. So in step number 3, we calculate the product mix. First of all, the P product. And the P product, the demand is 100 units times 15 minutes, which is the time on machine B, the constraint. And it will be 1,500 units. Remember that we have 2,400 minutes in the entire week. So now we have 900 minutes to produce Q products. 900 minutes over 30 minutes, which is the time that a Q product needs to spend in the constraint machine, this is machine B, will be 30 units. So the product mix will be 100 units of P and 30 units of Q. In step number 4, we calculate the profit per week. First of all, 100 units of P times the margin profit. And for the P case is $45 per unit, and we get $4,500. Now 30 units of Q times the margin profit, and we have $60 per unit for this case, and we get $1,800. The total will be $6,300 minus the operation expenses. This information is obtained from the diagram as well. And we get $6,000. So, $6,300 minus $6,000, we get $300. This is the maximum net profit per week. Summary. We need to produce 100 units of P and 30 units of Q. And we will get $300 as the maximum net profit per week, just for this case. I hope it will be helpful for your collaborative activity, and see you next time.